Hey, welcome back. In this video, we're going to learn how to let one operation in JavaScript complete before you move on to the next one. Throughout the video, you'll see me working in different code pens. You'll find links to those in the description so you can work through them and follow along with me. Essentially, the first code pen link uses old, maybe you could call it outdated or traditional callbacks. And then the second link, the second code pen, uses promises. Anyways, when you open the code pen up, the JavaScript column might look empty at first, but if you scroll down to the very bottom, you'll see that I've already created functions called get cats, get dogs, get birds in super secret order. The idea here is that 9 times out of 10 in the real world, you won't need to create your own promise as much as you'll just need to know how to leverage or use a promise that a library or package or framework is offering you. So throughout the video, we're just going to be leveraging these get cats and get dogs functions. That's just something to be aware of. So make sure that you're actually in the code pen so you have access to that code. One last thing before we jump into the action for this video, and that is that this video is sponsored by me. If you enjoy this video, you might enjoy one of my premium full-length courses available on Udemy. In the description for this video, you'll find a link to this page I'm showing right now with super discounted coupon codes for all of my premium courses. Having said that, let's jump into the actual lesson of this video. Okay, so this first part of the video is sort of a history lesson. It's about callbacks, and callbacks are not the newest, coolest, most elegant way of doing things. However, even if you yourself never write callbacks, you'll still inevitably run into a project that you inherit, or a library or framework or package or API that does use callbacks. So it's good to be familiar with them. Let's review them, and let's also see why they are less than ideal, why they can be super frustrating to work with, and why we needed a more modern alternative in the first place. In other words, let's begin by looking at the problem that modern alternatives like promises and async await are solving. So for the next few minutes, let's discuss callbacks. So some actions in JavaScript can happen immediately. For example, if I say const favorite number and I set that to 2 + 2, JavaScript can complete this action in 1 nanosecond. Right? So then if the line right below that you tried to log it to the console, or really just use it in any fashion, that would be fine. That would work perfectly. However, other actions do not complete instantaneously. So if I said const cats equals, and then I called the getCats function, and you can use your imagination that this function goes out onto the internet and retrieves data from some other server. So it needs to make a network request, and obviously anytime you make a network request, that can't happen immediately. Even on the fastest internet connection in the world, that's going to at least take, a couple of milliseconds. So the point we're getting at here is if on the very next line of code you tried to use that cats value, this would not work. JavaScript doesn't necessarily know that we would need to wait for this operation to complete before it moves on and parses or executes the next line of code. So the whole point of this video, the point of callbacks, the point of promises, the point of async await, is how do we deal with this situation where we need to do something and we have no idea exactly how long it's going to take, but we want to wait until it completes before we move on to the next step. Well, in this first code pen example that's using callbacks, because getCats is expecting a callback function, we can't rely on it to return a value like this. So even though we would like to write code that looks like this because it's intuitive and it's simple to look at and read, we can't do this if we're going to use the callback approach. Instead, you just call getCats and it's just sort of sitting here floating in outer space. We're not storing it in a variable. And then in the parentheses when we call it, we give it an argument that's a function. And then it's going to call that function once it's completed. Might take 5 milliseconds, might take 5,000 milliseconds, but once it actually completes and it calls that function, it's going to pass the data we're interested in into that function. In other words, in these parentheses, you would say function, parentheses, curly brackets, and then in the parentheses for this function, we would include a parameter. Now you could call it anything, x, animals, results. Why don't we call it cats? Because I think we can guess that that's what getCats is going to give us. So eventually, once getCats has finished its job, it's going to call this function. It's going to pass the resulting data into this function. So now in the body of this function, we can actually access whatever we named that parameter. So we could say console.log, whatever you named it, cats. And if we check the console, perfect, we see an array with 3 items, meows a lot, purrs loud, and biscuit maker. Now at the moment, you might look at this and think, hey, this isn't that bad. And maybe that's true. If you're just performing one action, like get cats, the callback approach isn't horrible. However, the moment you need to perform multiple actions like this and have them depend on each other or sort of sequence them, that's when things become a nightmare. So for example, let's look at the task up here that I've set up for us. So imagine we're supposed to retrieve the cats, the dogs, and the birds, right? So each one will return an array with 3 animal names. And then we want to combine those into an overall array. And then we want to pass that array of 9 animals into super secret order. And then it will sort or order the animal names in a particular order and give that back to us. And you can use your imagination that this super secret order function has complex logic and needs to run on a server somewhere. Maybe it's looking up all sorts of data of its own for its sorting algorithm. In other words, imagine that it also requires a network request, so we don't know how long it would take. So this is where things with callbacks get very ugly very quickly. So we've gotten the cats, now we need to get the dogs. So here's what you would do. We can get rid of this console.log cats, but we're still within this body of the function. Now, within the body of this function here, we know that we have access to cats. So then we would just want to also get access to dogs. So we could call get dogs, parentheses to call it. Now, you remember, you give that a callback function. So function, parentheses, curly brackets. Within the parentheses, we'd include a parameter. Let's call it dogs. Now, inside the body of this function, we could log dogs to the console. But we're still not done. We want to retrieve the birds. So another level nested deep, we'd say get birds, parentheses, function, parentheses, curly brackets, birds. Okay, now finally, now that we're 3 layers nested deep, we could combine cats, birds, and dogs, and then pass that into the super secret order function. So I'd probably just say const all animals equals cats, and then I would just concatenate on dogs and birds. So we could test this out. We could say console.log all animals. Check the console. Cool, so I have an overall array with 9 animal names. So now that's what we would want to pass into this super secret order function. So right here, I would just call super secret order. When we call it within these parentheses, we're going to give it 2 arguments. So first, you give it the list of items that you want to sort. So we named it all animals. And then the second argument is a function that you want to run once the super secret sorting operation has finally completed. So we give this a callback function, parentheses, curly brackets. Within the parentheses, we need to make up a parameter. Let's call it maybe sorted names. And now within the body of this function, now that we're 50 billion layers nested deep, we can finally log to the console sorted names. Check it out. Perfect. There's all 9 names. Now, yes, if you look closely, all it did was order them alphabetically. And you wouldn't actually need a network request to sort something alphabetically, but we were just using our imagination that we needed some sort of complex, server-side logic to sort the items for us. The point here is that this type of code is so messy that if we can avoid this, we absolutely want to. This is difficult to look at and immediately understand what's going on. It's way too many layers nested deep, so it's unmanageable. Not to mention, the way that this is currently set up is super, super slow. Let me explain. It has to do with the ordering of our events, or sort of which ones depend on which other ones. In other words, when it comes to calling super secret order, yes, we do want to wait for all of the get animal functions to actually complete before we run that. Right? So this depends on these ones being completed. However, if we forget about the super secret order and we just think about the 3 animal functions, they don't need to depend on each other. The ordering of which one finishes first does not matter. So with this current setup, we're needlessly waiting. We're wasting time. because we're waiting until getCats finishes, and it might take up to a full second or two. And then only then are we letting the getDogs request begin, and then it might take a full second or two, and then only once it completes are we actually beginning the birds request. So instead, what we would want to do is start up all three of these requests at the same time, and then we don't care the order in which they finish, but just once all three of them have finished, then we would want to run this. Now, unfortunately, JavaScript doesn't have any built-in way of managing callback functions like that. So you and I would need to take matters into our own hands and get a bit creative. So for example, maybe I would do something like this. Let me start over. I would create an overall variable and maybe call it all animals and set it to just equal an empty array. And then right below that, I'd create a function. I'll just name it maybe our logic. And I'd have an if statement. The condition would be if all animals dot length. So if this array contains 3 items, right? Cats, birds, and dogs. So only if we have all of the items that we're interested in, only then are we ready to call the super secret order. Before I fill out the code that will go here, let me show you how I would actually use this array in this function. So below this, I would obviously get cats. We know that we give that a function. To make this copy and pasteable, I'll just say the parameter can be called x. And then within the body of this function, I would just say all animals, and I would push onto it the array of cats. And then still within this same function, I would just call our logic. So now I would just copy and paste this for dogs and birds. So literally just duplicate it, call get dogs, paste it in again, call get birds. So the idea here is all 3 of our requests are going to start at the same time. Yes, we've listed cats first, but when JavaScript runs through our code, there's nothing here that tells it to wait before moving on to this next line of code. Now, when you're dealing with network requests, there's no guarantee that the one you call first will finish first. So we have no idea the order in which these 3 are going to finish. And that's fine. The order in which they finish doesn't matter. But what does matter, and this is the whole reason we created our babysitter, our logic function, really the job of this function is just to keep track and make sure that all of them have finished. So when each request finishes, we're calling this reusable our logic function. So each time it runs, we're just saying, hey, have all 3 of them finished? Does this array actually contain 3 items in it now? If it does, we're finally ready to move on to the next step. So then within this if block, let's create one flat array with all 9 items. So const all names or all equals all animals, first item in the array, and then I would just concatenate on all animals, the second item in the array, and all animals, the third item in the array. Cool. So now this is what we would pass into super secret order. So super secret order, you give it 2 arguments. So the first is all, and then the second is a callback function. So let's have a parameter, let's call it sorted names, and then finally we could say console.log sorted names. Now if we check the console, you might see a bunch of error messages in CodePen because it's trying to run your code anytime you stop typing for a little bit. And obviously when your code is halfway typed in, it's not going to work. So you might need to just save your progress and then completely reload the CodePen page. Anyways, the point here is that our code is working, only it's a lot faster than it was a few moments ago. Because the dog's request isn't having to wait for the cat request, and the bird request isn't having to wait for the dog request. So this is what we want. However, at what cost? I mean, this code is hideous. We shouldn't need to use this much brain power and this much typing to accomplish something this simple. So at this point, the history lesson of the video is over. I think we've established that using callbacks like this is terrible. For a long time, this was our only option in JavaScript, so we did things this way because we had no choice. However, in the modern world, there is something called a promise that solves both of these problems. So number 1, it solves the ugly code indentation problem. And number 2, it solves the letting multiple requests start at the same time. And if you don't care about the order, letting them all finish before moving on to something else. It solves all of these problems and more. So right now, let's jump into the next chapter and learn about promises. Okay, so you can see I'm in a new different code pen now, and we're working with promises. So we have the exact same example task. There are functions called get cats, dogs, and birds. And our goal is to combine all of them and then pass that into super secret order. Only this time, these functions do not expect a callback function. Instead, these functions return promises. What in the world does that mean? Well, let me show you. So down here, if we use the getCats function, we call the getCats function, it's going to return a promise. So basically at the end of this line, right, whatever this function returns, we are now working with what it returned, which is a promise. So whenever you have a promise, it has a method that you can call of then. The idea here is that we don't know how long the getCats operation is going to take to complete or resolve, but whenever it does finish, then is going to call a function that we give it. So in these parentheses, you could just give it a function. When then calls our function, it's going to pass into it the result of whatever the promise resolved with. So in these parentheses, we just say cats or make up some parameter name, and then we could console log cats. Cool. Now at first glance, you might think, how is this any better than using callbacks? Because at first it looks very similar, right? We're still having to give it a function and it looks a little bit indented. However, what if we wanted to chain on another action? So for example, we wouldn't actually need the get dogs to wait until get cats finishes before it begins, but just for a quick example, pretend that we did want to wait for cats before we run dogs. I want to show you how you could chain on another promise. So for example, we've already called .then on this first promise. Wouldn't it be cool if at the very end of this line of code here, if we could just call .then again? Well, we can. So all we need to do within this function is just return another promise. So if we say return get dogs, right, that's going to return a promise, and now that's what this overall function is returning. So in other words, at the end of this line of code, we're dealing with a promise, a new promise once again, and on that you can just call .then. And then the process just repeats. So we give that a function, give it a parameter, and then we could log that to the console. Check it out. Cool, there are the 3 dog names. So the idea with promises is that, remember with callbacks, you keep nesting in another layer deep, another layer deep. Well, with promises, you're always just staying that one level deep. So you could chain on as many promises as you want, right? By just calling .then, .then, .then. So this is already at least a little bit better than callbacks because we're always just staying one level nested instead of going infinitely deeper. However, let me start over because right now I want to show you one of the biggest reasons why I like promises. So in reality, we don't need dogs to wait until cats finishes, and we don't need birds to wait until dogs have finished. So remember with callbacks, we had to get creative and create our own babysitter function that made sure that all of them had finished. Well, with promises, the browser or JavaScript itself can babysit them and make sure that they've all finished before moving on to something else. We can just say uppercase promise, right? This is something that exists in the JavaScript language itself, and then it has a method called all. Now in these parentheses, we give it an array of promises. So I'm going to give it get cats, comma, get dogs. Whoops, you would actually want to call the function, right? Because that's what returns the promise. So get cats, get dogs, call it, get birds, and call it. And actually, you might be wondering, why can't we just give it a promise directly? Why are we always calling a function that returns a promise? Well, if you scroll down to the very bottom of this code, you can see the example promises that I've created to sort of simulate a network request. And the reason that when you're working with an API or a library, that you always call a function that returns a promise instead of just working with a promise directly is because as soon as the browser or node sees a promise, it's going to try to start resolving or executing it immediately. However, if you're only creating a promise within a function definition, obviously that's not going to exist until you actually call the function. So technically, if you wanted all your promises to begin working as soon as the script loads up, you wouldn't need to wrap them in a function like this. But 9 times out of 10, when you're calling a promise, you're usually doing it in response to something, right? Like the user clicked on a button or some sort of request is coming through on a server. In other words, you want to control when the promise begins working. So that was just a quick tangent. That's why usually you'll call a function that returns a promise instead of just working with a promise directly. Anyways, here we have the situation where we don't care which order these three operations finish in. We just want to wait for all of them to finish before moving on to the next step. So we can use uppercase Promise.all. At the end of this line, we can call .then. Within then, you give it a function. In these parentheses, we can make up a parameter name. Why don't we just call it results? And now the question becomes, well, what exactly is results? Well, we gave this an array of 3 promises, so this is going to match what we gave it. In other words, it's going to be an array with 3 items, and it's going to be first whatever this promise resolved, then whatever this one resolved, whatever this one resolved. So what do we want to do within our function here? Let's concatenate all 3 of the animal names together, and then we would want to call the super secret order and give it all 9 of the names. So I'd probably just create a variable and call it all animals and set that to equal, and then I'd look in results for the first item in the array, right? That's whatever get cats resolved with. And then I would just concatenate on that whatever the dogs resolved with. So that would be results, look inside it for the second item in the array. Still in these parentheses, just comma, we want to concatenate on something else. Results, look inside it for the final item in the array. Cool, so now we have this list with all 9 of the animal names. We want to pass that in to super secret order. But remember, we're imagining that the super secret order takes time to finish its super advanced sorting algorithm, some sort of server operation that takes time. So within this function, we can just return another promise, right? And then we could call .then right here. So we would just return another promise. We can return super secret order. This will return a promise. In these parentheses, we want to give it the items that we want to sort. So that would just be all animals. So now the fact that this overall function that I'm selecting, the fact that it returns another promise means that at this overall end of our line of code, we could just call .then. So now we're waiting for this promise to actually resolve. So then we would just give it a function. When it finally finishes, this function will run. We can name our parameter whatever we want. Let's call it sorted names. And then we could log that to the console, sorted names. If I check out the console, cool, there's the array with all 9 items and they have been sorted. Now, yes, we could clean this code up a little bit further by using ES6 arrow functions instead of actually saying function, right? And this entire bit of code could sit on a single line if you used ES6 arrow functions, but I'm gonna let you in on a little secret. Even if you did that, this code is still not going to be a perfect 10 out of 10 in terms of readability, in terms of looking at it and immediately understanding it, because we're still in this awkward situation of having to spell out anonymous functions and passing in parameters. And even though we're not nesting multiple layers deep, we're still having to awkwardly chain on .then. So even though the underlying promise technology is amazing, right? And being able to let multiple requests start at once if we don't care about the order in which they finish, even though that is great from a technology standpoint, this promise syntax and the way that we work with it is not the best. It leaves a lot to be desired. So for the final chapter in this video, now we're going to talk about something called async await. Now here's the cool part. We don't even need to jump into a different code pen. So I'm just going to delete these few lines of code here. I'm starting fresh, but I'm in the exact same code pen. I want to stress that point because async await really, at the end of the day, isn't any different than promises. It's still directly using promises. It's just a different syntax. It's just an alternative, cleaner, more intuitive syntax of working with promises. But it's the same underlying technology. Before we get started, I want to bring this full circle back to the very, very beginning of this video. Remember when I had a little bit of code that said, a variable of favorite number and it equaled 2 plus 2. And then on the next line, we could just log that to the console. Ultimately, this is great code. This is the type of code we want to be writing. You can look at this and you immediately understand what's going on. You performed an operation, and then on the very next line of code, you're not indented, it's not within some sort of callback function, it's just simply the next line of code. You can use what you just created. This is very intuitive and it's easy to make sense of. Well, we can write code like this if we use async await. So check this out. Imagine if we wanted to say const cats equals and then just call our getCats function. And then imagine if on the very next line we just wanted to log out the results of that. Well, this literal code on itself won't work, but wouldn't it be cool if before we call getCats here, if we could just magically say await getCats, and then JavaScript somehow knew to wait for this line to finish before moving on to this line? Well, we're just one step away from having this work. So in modern JavaScript, you can use await like this, but in order to use it, you need to be within an asynchronous function. So for example, if I just cut these two lines into my clipboard and then I create an asynchronous function, I'll name it go. You could name it anything, right? But you're just creating a function definition, and then on the line right below that, just call the function that you created. And you can see, just like you would normally create a function, but before the word function, you include async. So now that we have an asynchronous function, if I paste this code back in, we can use this magical word of await because we're inside an async function. And believe it or not, this code works. Even though it looks like it's too simple to work, it still works. CodePen got a little bit confused because in the middle of typing it tried to run my code, so I just saved my progress and actually reloaded, but you can see it works perfectly. So what does await do? Well, we use await when we want to wait for a promise to finish. I don't know about you, but this syntax looks 100 times cleaner than the .then syntax. This is why this has become the industry standard way of working with promises in JavaScript. You await a promise, and now JavaScript will not move on to the next line of code until this actually finishes. So it's a common practice. You use this, and then whatever this resolves with, well, you can just store that in a variable, and then you can use it in the next line. Let's actually work through the whole example of combining all 9 of the names and then sorting them. So check this out. Within my go function, because dogs doesn't need to wait for cats and birds doesn't need to wait for dogs, we would want to run all 3 of those promises at once. So I would say const, and we'll circle back to this in just a moment, but for now I'm going to say x equals, and then I would await uppercase Promise.all. So remember this, in these parentheses you give it an array, and you can give it as many promises as you want, and all of them can run at the same time. It doesn't matter the order in which they finish, we're just waiting for all of them to finish. So I would say get cats, comma, get dogs, comma, get birds. Now, let's circle back to this x. So we know that when this actually finally finishes, it's going to return an array with 3 items in it. So we can just use modern JavaScript destructuring. Instead of an x here, for the variable name, let's include an array, right? Square brackets. And we're just destructuring the array that it's going to return. So we know the first item will be the cats. We know the second item will be the dogs. We know the third item will be the birds. So now on the next line of code, I mean, it doesn't get much better than this. We can now use the data. We've given them very intuitive names. We're not nested inside a callback. This is great. So now we would just want to concatenate or squish all of them together into one array. So I would just say const all animals equals cats and then concatenate on dogs and birds. Or you don't even need to save this into a variable. You could literally just use this on the next line of code, but that's what we would want to give to super secret order. So I would say const sorted names equals, and then I want to await the super secret order, right? That's going to return a promise. I don't know how long it's going to take, but I want to wait until it actually finishes. When you call this, you give it the animals that you want to sort. So I'll give that all animals. For cleaner code, you could literally just include this within these parentheses here. But the idea is that now on the next line of code, once this actually finishes, only then will we move on to this line. So then we'd be ready to log sorted names to the console. So if I check the console, Perfect, all 9 names in the super secret order. Yes, we've already done this 2 times in the video, but this time our code is very readable. You could come back to this code a year or 2 in the future and you could look at it and immediately understand what's going on. Here's a quick tip. If you really don't want to have to create a named function and then call that named function, right, just to have an asynchronous function, you could use an immediately invoked function expression. To do that, you don't need to name your function, so I can get rid of the name of this function. So it's just an async anonymous function. We don't need to call the function. There is no function named go any longer. Instead, you would wrap the entirety of this function in parentheses. So open parentheses here and then closing parentheses here. And then directly following that, just a pair of parentheses to call the function that just came right before it. So this is called an IFE or an IIFE, short for an immediately invoked function expression. But if we check the console, you can see it's working just fine. Essentially, this lets you use await because you're still within an async function. Okay, now there is one final thing I want to talk about before we bring this video to a close. So we've seen that async await isn't a new technology. It's just a different syntax for working with promises. So remember when we first learned about promises, we used the .then syntax to work with a promise. Here we're mixing and matching. We're using the async await syntax to work with promises, right? Get cats, get dogs, get birds, return promises. But you could flip it the other direction. I'm not sure why you would, but you could use the .then syntax to await an asynchronous function. If that didn't make sense right now, that's okay. And this really isn't something you would do in the real world necessarily, but I want to take the time to walk through this example so that you really understand that async await is not its own new thing. It's just a different way of working with promises. But hang in there with me, and I actually want you to do this with me. So I'm going to delete this example code. If you want to comment it out or save it somewhere else, you can, but I'm getting rid of it. And now in the real world, 9 times out of 10, you won't be creating the promises. You're just leveraging the promises that some sort of library or API is providing for you. But maybe sometimes you will want to create your own promise. So if you scroll down towards the very bottom of this code pen, here is the get cats promise that I've created. It's simulating a network request. And here we see the actual word, uppercase promise. So clearly this is using the promise syntax. So this is using the promise syntax, and we've seen how you can leverage it using both .then and async await. However, what if this wasn't using the promise syntax? What if this was just an asynchronous function? Let me explain. So let's just entirely delete the getCats function definition. So we're starting fresh. And let's say async function named getCats. And we know that in a function you can return a value, right? So if we return just an array of names, right? Let's say Meowsalot Jr., comma, purrs loud. Let's just have 2. Well, this isn't just a standard function that's returning a value, it's an asynchronous function that's returning a value. And behind the scenes, JavaScript is going to turn this asynchronous function into a promise. And the value that you return is the same thing as the value that a promise would resolve. Now, without any sort of delay, like simulating a delay of a network request, this isn't going to be very impressive. So, for example, if I just paste this code in, if you want to pause the video and type this in, you can, but essentially I've just created a promise called delay, and it's just going to wait a random amount from somewhere between 1 millisecond up to a second. But the idea is in our getCats async function, maybe before we return our value of 2 names, imagine if we wanted to await a delay of some sort. Right, just to prove that this isn't a typical function that can, in the span of 1 millisecond, return a value. This is an asynchronous operation that's going to have a delay or take some time. Okay, but the idea is we've named this function getCats. However, JavaScript turns this into a promise, so now we can leverage it or actually use it just as if it was a promise. So check this out. Back up at the very top of our code, we can use either the .then syntax or the async await syntax. I'm not sure why you'd want to use the .then syntax, but we could say get get cats, call that, that returns a promise. Say .then, give that a function. We could name this whatever you want, cats, and then we could say console.log cats. Check the console, meows a lot junior and purrs loud. So even though we defined getCats as an async function, it's the same thing. Async await is just a different way of working with promises. So we're leveraging this the exact same way using the .then syntax for promises, or if you wanted to use async await, you could. So if we had async function named go, and then we called go, but then inside the asynchronous function, if we said const cats equals await get cats, and then right below that, tried to log it, cool, we see that works as well. So if that didn't make perfect sense, I realize I moved very quickly, but the picture that I'm trying to get across to you is that async await is just a different way of working with promises. It's nothing new. It's just syntactical sugar. So if you understand one, you basically understand the other. It's just a matter of practicing and getting familiar with both. Having said that, at the end of the day, async await, this syntax that we see here, this has definitely become the industry standard way of working with asynchronous operations in JavaScript. Before we bring the video to a close, I do want to briefly mention error handling. So if you're using the async await syntax, a nice way of handling errors is just to wrap things in try catch blocks. So for example, I'll temporarily cut that into my clipboard and you just set up a try block, and then right below that you can have a catch block. When you call catch, it's nice to have parentheses error so you could actually look at the specific error, but you include the code that you want to run in your try block. In the catch block, you can do whatever you want. You could use the error that gets passed into it, or you could just log a message that says, please try again later, right? You can do whatever you need to do. But we see that we don't see that error message because the code is working perfectly. However, if we go back down into our getCats function definition, so we have an asynchronous function that's sort of acting like a promise. We're leveraging it like a promise. Well, in an actual promise, it uses the terms of resolve and reject, right? So when something happens successfully, instead of returning a value, in an actual promise, you resolve the value. Or if you ran into an error, you could reject with an error. Well, in an asynchronous function, when you return a value, that's the same thing as resolving. If you wanted to reject with an error, you could just throw a new error. And let's say the sky is blue. This is bad. So if we check our terminal now, we see the please try again later message from when we were actually leveraging things up here. Or if we wanted the message that came from the asynchronous function, you could actually just log the error message that's being passed into it. So now we see that message. The sky is blue, this is bad. And remember, if you wanted to use the .then syntax instead of async await, in addition to .then, you can include a .catch at the very end, and that's how you handle errors from that direction. I know we covered a lot of ground in this video, and maybe everything didn't make perfect sense, but don't worry. I mean, this is one of the most complex and difficult to understand concepts in all of JavaScript. This is one of those topics you might need to watch this video a second time, or, go search on YouTube for a different tutorial from another channel. But in time, I hope these concepts start to make sense for you. I hope this video was helpful and that you feel like you learned something. Thank you so much for watching, and stay tuned for more web development tutorials.